When we are talking about ions, we're just talking about subtracting or adding electrons to our valence shell. For example, aluminum and aluminum plus 3, we knock off 3 electrons from our valence shell. Now for transition metals are a little weird. So transition metals will usually form cations and the electrons are removed from the valence shell, the outermost shell. Once we remove electrons from the outermost valence shell, then we just remove electrons from the next outermost shell. For example, iron has this electron configuration where 4s is the outermost shell and then it's 3d6. So when removing electrons, always remove them from the biggest number first. Don't always remove them from the last number first. And so when we go to Fe2+, we lose the 4s2 electrons first, and then if we continue to get the further cations, we lose electrons from the d orbital. Now for our ions, the atomic radii, if we're talking about columns, everything has the same charge. So column 1 plus 1, column 2 plus 2, column 7 minus 1. And as you go down the column, you'll have larger ions, because you'll have more shells, just like we talked about already in this video. When you compare cations to neutral atoms, cations are smaller than neutral atoms, and anions are larger than neutral atoms. And your cations will be smaller than your anions. And when we look at the actual charges, the more positive charge you have, the smaller you'll be. The bigger negative charge you have, the bigger you'll be. And this is only when we're comparing atoms with the same electron configuration. If we're talking about atoms with different electron configurations, we can't make nice comparisons like this. So let's look at cations. So what I'm showing here, here's your neutral atom, and here's your cation. You can see they are way smaller. And the result of this is we knock an electron out of this outermost valence shell, so we lose that shell, and now the electrons themselves are being pulled tighter in. So that has a twofold effect. We knock out the outer shell, and now our electrons are being pulled in further, so they have a greater charge. And if we compare cations with this bigger charges, the same electric configuration, you can see they get smaller and smaller still. So let's look at our periodic table. So if we move from up to down, we have bigger radii for our cations, and from right to left, we have bigger radii as well for our cations. Now let's look at anions again. Neutral atom, charged atom. Our anions are bigger than our neutral atoms because we are adding electrons to our valence shell. These valence electrons have similar effective nuclear charge, but they are repelling each other. And so since the electrons are repelling each other, they move farther apart from each other, and they create bigger anions. And the more negative charge you have, the slightly bigger anion you have. If you're comparing the numbers in blue, they're slightly bigger for bigger charges. Not much, but slightly. And our trend for this is, again, up to down is bigger, and left to right are bigger as well. And that's it for this video. See you in the next video.